Hello everybody, my name is Chandra and this video is for the dimension reduction, one of the data science topic. So let's begin with this. So we have again we have two agenda here, demonstration how you will identify multicollinearity and demonstration on how you will apply principal component analysis, that is PCA. So in the demonstration of multicollinearity, how can we identify? Okay, I have something discussed. You can just ignore this line, first line. So it is an important step in regression analysis to ensure that the predictor variables are not highly correlated with each other. So multicollinearity occurs when independent variables in a regression model are highly correlated with each other. This can lead to unstable and unreliable model coefficient. So here are several methods to identify. So basically, we can use correlation matrix, we can use a variance inflation factor and tolerance condition matrix, condition indexing, and many more. So for that we have this example here, just run it. So we have a VIF here, that is a variance influence factor. So this is the variation, that is the constant. Okay, so this is how you can find a multicollinearity. And the next topic is how you will apply PCA, that is principal component analysis. It is also a powerful technique for the dimensionality reduction, which helps in simplifying complex data sets while retaining most of the variance. So in this, what is a PCA? So PCA is a dimensionality reduction technique that transforms a large set of variables into a smaller one that still contains most of the information in the large set. So we have steps involved in this: standardization, covariance, matrix, and PCA. So we have also one of the example here in the coding part. So it's a practical example. We are using a standard scale and fit transform and transforming in the PCA. You can pause the video and watch this code. So this is the PCA example, as you can see. Okay, so this is for the dimensionality reduction. Thank you, and thank you for watching this video. See you next time.